So in the last experiment, as you told, we studied about comparators. Can you tell me just a glimpse of what we did exactly there in the experiment?
So can you repeat the question?
Um, you said we studied comparators, right, in the last experiment. So
Yes,
can
sir.
you tell me something about the experiment? What did we study? Few key points.
Uh, so A equal to B is A dash B dash plus AB.
Okay,
A less than B. A less than B is A dash B.
okay,
A greater than B is AB dash.
good. But how did we come across these equations? How did we get these expressions?
Truth table.
Truth
Okay,
table, sir.
okay, good, truth table. And how did we compare them? Like, for example, if it's 4 bits, A not A1, B not B1, then how did we compare them?
For 4 bits, sir.
Yes.
For 4 bits, we will compare uh, A3, B3. If it is
Mhm.
greater, then it is greater.
Good.
If it is lesser, it is lesser. If it is equal, we will go to A2, B2.
Correct. Correct. So
So
we
we
are
will repeat
bit
this
by bit,
procedure. Yeah.
right?
Yes, sir.
Okay, Darshan, thank you. So remember, all of you, as you participate in the lab, okay, your marks also will be allotted because there is 15 marks allocated for each lab. Okay, so I hope you all understand. One is for your attendance, one is for your observation, okay, and one is for your interaction as to how you interact in the lab. Okay, fine. So today we will be looking into experiment number 7, okay, which is nothing but implementation of encoder and decoder. So I think all of you have gone through encoders and decoders, right? Can someone tell me what is it exactly?
Decoder will convert binary data to single data output,
Okay, are
and
you sure?
encoder will do the reverse.
Are you sure? Is it necessary that we need to have only one bit output?
Uh, one pin output, sir.
One bit. Is it only one bit or how is it?
I'm not sure, sir, but I guess it is 1 bit.
Okay. Now, if you look at these diagrams here, okay, you
Two
have
power
two
and output will get, sir.
exactly. So you
For
have
n input, two power and output.
correct. So if you have two inputs, okay, so as Suprit suggested, okay, it's going to be 2 power n. So which means if I have 2 here, then I'm going to have 4 outputs, right? So in this experiment, we'll be studying about encoder, decoder, and priority encoder. Now, what is a priority encoder?
It gives priority to the highest number.
Highest number. So if in case the lower bits are enabled, still will it work? Will it give any
No, sir.
importance? No, right?
No, sir.
Okay. Why is this needed? Why is it necessary to have this kind of priority?
In some cases, you need to consider only the highest number to use this.
Okay. So in some applications, okay, in order to uh, make sure that only the highest bit is taken up, so we go with priority encoder. So based on your applications, okay, we either choose an encoder or a priority encoder. So in today's experiment, we'll be actually looking into all of these, okay, which is encoder, decoder, priority encoder, and we have specific ICs. which actually perform these functionalities. And not only that, we have a chip, okay, we have an IC, which actually helps us in getting the LED display functionality also implemented. So for that, we'll be using 7447 IC. Okay. So if you just Google, you can actually get its data sheet. Okay. Can someone tell me what's the data sheet?
It contains all the pin numbers and specifications.
Okay. So what does specification involve?
The supply voltage,
Okay.
etc.
Yeah. So basically, it contains all the characteristics of your integrated circuit as to what temperature is good for it to operate well. Okay, what is the maximum temperature that we can operate? What is the minimum temperature? How much of voltage to be given? Okay, and all of its properties, including some of the data sheets, will also involve few graphs. Okay, then as you suggested, even the pin numbers also will be given. Okay, right. So here now let's get into the experiment. Okay, and we'll be having LED display and resistors of 330 ohms. We do have this color coding, right, BB Roy? So this color coding of resistors will be utilized and understood as to how much is the value of each resistor, and we'll be having this wires, okay, which you need to connect. Fine. So the first one that we'll be seeing is the decoder chip, which needs to drive the LED or LCD display. Now, whatever combination that we give, okay, that should be understood. Okay, that should be understood by your IC. So, in order to get that function done, we have this decoder uh, component, and then we even have your decoder 3 is to 8. Okay, so as you all know, it's 2 raised to n, right? So 2 raised to 3 gives you 8 decimal outputs, right? Okay, so this is your pin diagram wherein your A1, A2, A3, A0. Okay, these are all your inputs. Can you tell me what is this LSB and MSB?
Least significant bit and most significant bit.
Okay, where will our MSB be, towards the left hand side or right hand side?
MSB, sir.
Yes,
MSB will be to the left.
yes, to the leftmost, right? Okay,
Yes, sir.
so here we will have MSB, and then here we will have LSB. So as it increases, okay, as it goes towards the left, the value will actually keep increasing. Just like your 8421, then after 8, what comes? 16, right? So ultimately, as we keep going towards the left, the value keeps on increasing. Okay. Fine. So this is your pin configuration, okay, wherein VCC is also there. Then you have this A, B, C, D, E, F. We will be using this C and G. Okay. So now I will tell you as to what is this A, B, C, D, E, F, G. Okay. Once we look into this diagram. So this is called your 7-segment display. Have you all seen this kind of display?
Yes, sir.
Where have you seen?
In our mini project.
In your mini project? Good. Practically, we even look at it in our traffic lights, right? Traffic lights also, you see this. Any display for that matter, it can be your electronic watch. Okay. So this kind of 7 segments are used. So here each segment, okay, each segment is an LED. For example, this is taken as A, and this is taken as B, C, D, E, F, G. Some will even have the decimal point. Okay, so that will be taken as H. Right. Okay. So this is how typically it looks in the form of your pins. Okay. Now if we dive deep into the circuitry and if we try to understand, okay, there's a diode which is used. Now each diode will have uh, two parts. Can you tell me what are those? The plus and minus, how do we identify?
The triangle part is plus and the line part is minus.
So what is it called?
PN
Okay,
Cathode and anode.
yes,
cathode.
cathode and anode. So ultimately here you can see that all the anodes, okay, all the anodes are connected together, right? So, so this becomes your anode, right? And this becomes your cathode. So all the anodes are connected here together, right? So we can term it as common anode. So similarly here the reverse also is possible. Okay, we can connect all the cathodes together. Okay, and then it is also called as common cathode. So now, why are we doing this? In order to pass the information through a diode. Okay. Now this is what you can see here: A, B, C, D, E, F, G. Okay, and this is used for your decimal point. Okay. So once this gets the value, okay, once this gets the voltage, that particular LED will glow. Okay. Say for example, if I want 3, if I want 3, so which all alphabets or which all LEDs should glow? Can someone tell me?
A, B, G, C, D.
Okay, good. So A, B, C, D, and G. So this looks like a 3, right? So similarly, can someone tell me how do we write 9?
Add F, sir.
9, 9. How do we get 9?
Yes, sir. 3 plus F.
Now here, which LEDs are to glow to make it look 9?
A, F, B, G, C, D.
Okay, A, F, this is your G, B, and C, right? So this will give us 9. So accordingly, okay, what you can do is towards one of your tabulation, okay, you can probably put the a decimal number 1, 2, or 3, and in your other column, okay, you can actually mention A, B, C, D, E, F, G. Okay, so put this across another column, and you can actually mention which will turn on. Okay, so for example, 3. So A should be on. Okay, then B should be on, C, then D, and then G. Rest all will be what? 0. Okay, rest
Sir,
all
how
will
you're
be
telling
0.
that? Sir?
Sorry,
How you're telling that? Sir?
it is just like, whichever is glowing, that will be high. Okay, so if A is glowing, A will be given 1. If B is glowing, B will be given 1. Understood? Now
Okay, sir.
let me again explain you how we get 3. How we get 3? I need this A, isn't it? Yes or no? Then I want B to turn on, right? Then I want C also to turn on. Then I want D also to turn on. And then I want G also to turn on. Yes or no?
Yes, sir. Yes, sir. Like this. Okay, okay. Yes, sir.
Right? So all this will
Yes,
be
sir.
1. Only these alphabets will be 1. Okay. Rest of the alphabets, A, B, C, D, E will be 0. Okay, this will be 0. E, F also will be 0. Understood?
Yes, sir. Yes, sir.
So towards your left hand side, you put all the numbers, and towards your right hand side, you write A to G. Okay, you write A to G, and accordingly you can fill in the tabulation column. Understood, right? What you have to do, all of you?
Yes. Yes, sir.
Hmm? Okay. So accordingly, you can try doing it. Okay, and you can put it in your observation. Is that clear? Right. So here, if we use common anode, if the anodes are connected together, then it's called a common anode configuration. If the cathodes are connected, then it's called a common cathode. Any doubts here? Till here, any
No,
doubts,
sir.
students? Okay,
No, sir.
fine. So I'll proceed. Right. So this is how your LED, your 7-segment LED display works. Why is it 7-segment? Because 1, 2, 3, 4, 5, 6, 7. There are 7 small LEDs, right? So it's called a 7-segment. Okay, right. Next, now we will be looking at the IC 7447. Okay. Now this is used for the implementation of your um, yeah. So here you can see that you have your inputs A0, A1, A2, A3. Okay, so this is nothing but your 7447. Okay, so I told you, right? A0 is 7, A1 is 1. Okay, A0 is 7, A1 is 1, A2 is 2, A3 is 6, A2 is 2, and A3 is 6. Right? Any doubts here, students? Okay. Now here you can see this A, B, C, D, E, right? This will be used as F and G. So this will be connected to what? This will be connected to your 7-segment display, right? And for that, we actually use your 5501. So this is your IC, which actually implements your 7-segment display. Okay. So in between, what we do is we connect a 330 ohm resistor, okay, which is inbuilt. Okay, 330 ohm resistor. Reason why we use resistor is because these LEDs do not require such high power, such high voltage, right? So they need very low voltage, and hence these resistors will drop the voltages that are across, and we will get a small voltage across this IC. Okay, so as your pin numbers are given here, okay, you can see that your 13 is connected to 7. So let us see what is 13. 13 is nothing but A. Okay. So which means this is your A. So if this turns on, okay, which means your A LED is turning on. Right. So that is only your 5501. Any doubt, students, as to how this connection is done? Any doubts?
No, sir.
Okay. So accordingly, what will happen is this will be A, B, C, D, E, F, G. Okay. So F is nothing but to your 15th pin. See, this one will be your F. We already have a C here. Okay. And G will be as usual 14. Okay. So that is interfaced with your 5501. With your 5501, and it has its individual VCC and ground. Right. Okay. Now, how does this function? Now, you have seen in your experiments where you have those buttons, right, where you can turn on and off, where it can be kept 0 and 1, right? So these three, okay, these four, A0, A1, A2, A3 is used for that purpose, okay? So which means, in what order is it? Just a moment. Which means in what order is it? So A3 will be my MSP or LSP? A3,
MSB.
MSP, right? And A0 will be here. Okay, right. So that is what you can actually see here in your tabulation. So here, what is the maximum number that we are going to obtain from this 7-segment display?
9, sir, up to 9.
9.
Yes, exactly, up till 9. If I want another one, then I will have to actually install one more 7-segment, okay, where one can be here, E and F, okay, and or I can even activate B and C for that matter, 1 and 0, okay. So I will need another 7-segment display to display up to 99, right? So this is capable of displaying only about 10 numbers, which is 0 to 9, okay, right? So which means I will not need all these values till 4 ones. I'll be needing values only till here, isn't it? Yes or no?
Yes, sir.
Yeah, only till here. So all this will become invalid. So all these values that you give here will all be invalid. This wouldn't work, okay? Because we are using only one 7-segment display, right? So the next one that you'll be seeing is your priority encoder. So till here, any doubts, students, till this concept?
Sir, in that IC, what is
Huh.
pin number 345, sir?
This is actually connected also to your VCC, to your higher value, okay? So you can see here,
What is the function of that, sir?
yes, see 345 is nothing but your BI, okay, RBI and your LT. So here you can see that your LT is nothing but your lamp test pin, okay? So that can be used as a test pin. You can just check if you know if it's properly functioning or not, okay, to check if all the other terminals are fine or not. So it's like a test pin, okay. Then your RBI is nothing but your ripple blanking input terminal. So what is this is, this is kept high when or you know this is made high, and also it makes all the terminals in on condition. So whenever this goes high, okay, whenever your RBI goes high, whenever your RBI goes high, it turns on all the other pins. If this is not on, then all the other pins will be in off condition. Understood?
Yes,
Right.
sir.
So 3 is used for testing, 4 is used to activate all the pins. Okay. And then your BI RBO is kept high for all the outputs. So it is like input enable, output enable. Okay. So this is nothing but your output enable. So from here, the outputs will go. So if I have this enabled, okay, if I have this input, this fifth pin enabled, it means this can accept inputs, okay. If I have this pin enabled, the fourth pin, then the output will be enabled. From here it can pass on, okay. And as you all know, your tree is for testing. Now before you use an IC, normally you put it in the trainer kit, okay. There's an IC tester actually, okay. As soon as you put the IC in the kit, you can just press the number 5501, and then it will tell you if the IC is good or bad. Have you all tried this IC tester kit?
No, sir.
Okay, so there's an actually small device, okay, where you can put your IC, and then you can just type in the IC number, okay. Let's say for example, if I'm testing this one, okay, so I will have to put the number 7447. So once I put this, all the terminals will be checked, and it will tell us if the IC is good or not, because sometimes there can be a broken connection inside, or sometimes there can be a short circuit inside, or sometimes there could be a minute damage, okay, which is not visible to our eyes because it's all packaged, right? It's a packaged circuitry. So which means inside I cannot see how it is. So in order to check that, okay, what we do is we connect it to a device, okay, and then we check if the IC is good or not. Yeah, are we clear till this point?
Yes, sir.
Okay, fine. So now we will move on. Okay, so we have finished our 7-segment display. We have finished our decoder. Okay, now we will get into something called priority encoder. Now, the concept is very much aware to all of you with regards to priority encoder. So the word priority is nothing but value is given to the uh, highest valued bit. Okay, so here, if in case, okay, if in case D naught is high, okay, so if D naught is high, that means it is corresponding to this 0. So which means I will be getting it in decimal, in binary form. So decimal form is 0 and my binary form is 0, 0. You have three output terminals here. One is Y1, Y0 and V. V is nothing but it will tell you if the output is valid or not. Understood? So here in the first case, all are zeros. So which means none of them are selected, isn't it? Yes or no?
Yes,
Yes,
sir.
sir.
Yeah. So that means it doesn't matter if my Y1 turns on or off. Either is it L, which means low, or H, which is high. So I have a don't care here, and the output is actually invalid. So that's why I have a 0 because none of the inputs are high. So here now let us see this case. So in this case, only D naught is turning high. So which means that will give me in my binary form, which is 0, 0. Next, you see here, D1 is also on, D naught is also on. Okay, but in this case, D1 has highest priority, higher priority than D naught. So D naught is not considered, only D1 is considered. So the binary equivalent is what? 0, 1. Any doubts?
No, sir.
No,
Okay,
sir.
yeah. And the output is also valid. Similarly, D2 when it goes high, so it's binary equivalent 1, 0. D3 when it goes high, binary equivalent 1, 1. So no matter even if this is 0 or this is also 0 or even if this goes 0 and only this is 1, still the output will always be 1, 1. Right? Understood?
Yes,
Yes,
sir.
sir.
Okay. Now what can be done is we can implement the circuit. Can someone tell me how is the circuit implemented? How did I get this? Hmm? How did I get the circuit? Normally in a digital electronics, okay, what do we do? Once
So,
we get the
We draw
truth
K
table,
map.
exactly, right? So you can take the k map of this y1, y0, and v separately, and you will get expressions, and these are the implementation of those expressions. I do not want to get into k map because we have almost finished our course, our DC course, isn't it? So by now you should know what is k map, what is MEV method, what is implementation table method, isn't it? So all of this you
yes, sir.
should know. Yeah. So using our K-map, we actually come out with these expressions. Now, while writing your observation, I want you to put K-maps for all of these. Y1, Y0, and V. Put K-map and you can extract the equations. And after equations, you put this circuit. Is that clear?
Yes, sir.
Yes, sir.
Fine. Now, after this, okay, what we do is this we have just employed for 4 bits. Okay, now this can be even taken up to next level, which is 8 bits. So, which means this will go um, up to what? D naught to till which value? If I take
D7.
exactly till D7, right? So D0 to D7. So here also priority encoder, if D7 turns on, then I'll be having Y0, Y1, Y2 as my output, and my output, if it's valid or not, just one bit is sufficient. So here, if it's a D7, then the output is going to be 1, 1, and 1, right? Okay, so this is your IC, which is actually used for 8-bit priority encoder, which is 74148 IC. Okay, so your inputs are going to be here. You will have 4 inputs. Okay, and here another 4 inputs. Okay, now here you have something. Yeah, here you have your outputs. Okay, which is uh, your E0. Okay, then GS, then your A1, your A2, okay, A0. So A0, A1, A2, these are all your outputs, and these 4 are your inputs, and this is your enable, okay, input enable, and this is your output enable. Okay, so similarly we can draw the uh, you know your truth table, okay, for your priority encoder, just like how we did for the 4-bit, just that instead of 0 they have written L, instead of 1 they have written H, which is high. Okay, one more thing that you all have to understand is this particular IC is active low. Can you tell me what is active low?
If
Now
it is 0, it works. If it
um,
is 1, it.
correct. Now for 7, normally how we write? 111, right?
Yes,
But
sir.
here for active low, for 7 it will be 000. That's the only difference. So what you can do is, in order to avoid confusion, you can probably create a table, manually create a table with D0 to D7, put it in your observation book, and use binary numbers, okay, instead of using your L and H. Okay, let's say for example, see your input enable. So your input enable normally should be high, but here we have everything low. It is because we have it in active low configuration, right? Okay, so if it is high, which means what? It's all 0, actually 0, right? So these are also 0 here. Then it will keep going one by one. Okay, so instead of writing this in L and H form, okay, it might be a little confusing. Okay, so what you can do is you can put them in the form of zeros and ones. Any doubts here, students?
So what is the last column, sir? GS and E0 in the.
This is
Yeah.
your yeah, this is your output enable. Remember we had here in your IC, just like how we had your output here, which enables the output, your BIRBO, right? Similarly, we have your uh, yeah. Similarly, we have your output enable. You know, GS is also a kind of output, okay, which is actually for your group. Okay, whenever grouping is done, remember we were doing grouping in our previous experiment. I'll show you. So this kind of grouping we were doing, right? So when I say cascading, right, cascading, so whenever one bit is compared, okay, and if those two bits are the same, it will try to compare the other two bits, right? Are you understanding, students?
Yes, sir.
Huh? So that is nothing but your grouping output. Okay, so it will check if those inputs are same, then it will do a grouping. Okay, so any doubts here, students, with this? So don't put L and H, just use 1 and 0. That will be better. Okay,
Yes, sir.
fine. Okay, so this is how we try to interface. We can see here they've used common anode configuration in this. Okay, and yeah, so basically that's about it for today's experiment. Okay, and I'll be sharing in a few more information to all of you, and you can go ahead and refer to that as well. Okay, so any doubts here, students, up till this point?
No, sir.
No, sir.
Okay, okay, fine. So just stay in the line, okay, and I'll be